So I'm going to talk about how to use the data specifically in the context of um, downloading an IPUMS extract and how to link that to the MLP crosswalk data. Just to give you a brief outline of what I'm going to be discussing today, I'm going to first start with just going and doing a really quick overview of the MLP web pages as well as the MLP crosswalk files themselves. At that point, I'm going to then go move to the process of downloading an IPUMS extract. I'm not going to do a detailed how to of this is how you select a sample, this is how you select a variable. I'm only going to be talking about what you need to do in the extract system in order to make sure that you can download an IPUMS extract that will work with the MLP crosswalks and making the file size as efficient as possible. For those who either haven't used the IPUMS extract system or just need a refresher, I have put a few links here in the PowerPoint that you can go to that provide more detail on precisely how to use the IPUMS extract system. Then I'll actually go through the process of showing you how to combine the IPUMS extracts with MLP crosswalk, and then going through a more advanced case scenario of what if you're interested in linking non-consecutive census years. Say the most popular census year was 1940 from the poll. Well, what if you're interested in linking 1900 to 1940? How do you go about doing that? And then because of one of the suggestions we give, we suggest doing case selection in the extract system. And so I want to kind of just briefly review some of the sources of error that can lead to you not being able to make links between your extracts because of the case selection criteria that you chose. So in the PowerPoint here, just to kind of give you a heads up, this is going to be mostly a brief overview. I'm going to actually be switching over to a different window view here to show you the actual MLP web pages. But any of the tips here or excuse me, any of the points that I have in bolded green down here, like at the bottom, are kind of tips and tricks that we've considered that you can try in order to again make using the MLP data and the IPUMS extracts as easy as possible. So at this point, I'm going to switch over to the IPUMS web browser. So the first thing to note is that the MLP data is currently stored under the supplemental data here on the left. So this is the home page for IPUMS. Under supplemental data is linked census data. And this is where you can find the MLP data. There's actually also the linked representative samples that Steve spoke of at the beginning can also be found here. And so for the MLP data, the very first link is the data description, which, as it kind of suggests, is just a brief description of the MLP data. The number of individuals linked between censuses, just a really quick overview of the linking strategy, the accuracy of the data, etc. The next link is a little bit more of a detailed description of the linking method itself, and this is what Jonas spoke about in his presentation. And then this is also where a link to the current working paper can be found as well. The downloads is where you can download the actual MLP files. Currently, we offer the MLP files in two formats, Stata format and a comma delimited, a CSV format. And this is also where the citation for the MLP data can be found. So if you use our data and publish your results, this is the citation you can use for the IPUMS MLP data. And then the final web page is just a really quick data user guide. And this is going to be mostly what I'm going to focus on today. We kind of have it split into two sections. What you do in the IPUMS extract system, and then also general instructions for after you've downloaded the data, how to link the data. So before I go, I'm going to show you the MLP crosswalks in just a second here. But the first thing I want to point out for Stata users, for Stata users, we do at the bottom of the user guide have a Stata do file that will actually do pretty much all of the linking for you. So, and by linking, I'm specifically talking about IPUMS extracts to the MLP crosswalks. So all you need to do is click on it, and then you can download the do file, which will link your two IPUMS extracts together using the MLP crosswalks. And I'll go over that in a little bit of detail later on, because I understand not everyone's a Stata user, so it's going to be less useful for those who don't use Stata. But for those who use Stata, I do want to show how it works really quickly. Alrighty, so this is what the actual MLP crosswalk file looks like. So I'm looking at the MLP crosswalk file for 1900 to 1910. The two important variables are are the HIST IDs for the two individual years. So each record is basically a linked person. So that you have the HIST ID for the person in 1910 and the HIST ID for the person in 1900. And this is what the variables you're gonna use to link your IPUMS extracts together with each other. Then there's the round variable, which is just basically indicating what step of the MLP process the data was linked on. And then in each MLP crosswalk file, we provide 6 variables. The 6 variables are serial and per num, sex, age, state FIP, and the detailed birthplace code BIPL-D. And we provide that for each year. So we provide the variables for 1900. We also provide the variables for 1910. And we provide those so that you can, if file size is an issue for you, say you're running this on your personal laptop, you don't have a lot of RAM, or your computer just doesn't have the CPU in order to do the linkage effectively, you can use case selection to basically make the crosswalk smaller. So for example, let's say you're only interested in studying people between the ages of, we'll just say 18 and 55. You could select those cases here and to make your MLP crosswalk smaller. And then also, and as a part of that, make it so that when you do actually link with your IPUMS extracts, that it goes a little bit quicker and easier. And you can do that with any of the variables provided. So the four variables are sex, age, detailed birthplace code, and state FIP. We do provide serial and per num in the file just to help if you're looking at the actual crosswalk file, that if you want to be able to see who's a member of the same household, you can certainly do that. I cannot stress this enough. Do not use serial and per num to link cases from your IPUMS extract to the MLP crosswalk. Serial and per num is not stable between versions of the data. HIST ID will always stay the same from this point forward. So this HIST ID for this first person, that will never change ever. This will always be their HIST ID. But as I mentioned in Steve's Q&A earlier, one of the things we're working on is making sure that the counts of in the complete count data match up as closely as possible to the published counts. Let's just say between now and March, we go through and say, well, there's a bunch of duplicate records here. We take them out. We rerun them through the IPUMS process. Now they have new serial numbers. So that means if you were to use an old IPUMS extract and link to a different version of the MLP data when it's been run, you might get bad matches, basically. So don't use serial and per num to link cases. You should only use the HIST ID variable to link cases. So I'm going to now transition to the IPUMS extract system. And on this, in the PowerPoint here, the first 4 points are 4 things that you need to do in the process of creating an IPUMS extract in order to make it work with the MLP crosswalks. The bottom 3 points are just kind of tips and tricks again for how to work with the extract system as effectively as possible. So I'm going to go back to the home page and we're going to go to the extract system. So the first thing you're going to want to do is when you select your samples, you need to deselect the default sample from each year. None of the sample data, including the historical samples, can be linked to the MLP crosswalk. None of these files have hist ID in them, so you can't link any of these data sets to the MLP crosswalk. So you should deselect the default sample as the first step in the IPUMS extract system. The only data that can be combined with the MLP crosswalk is the USA full count data. When typically when you select your data, a lot of users will tend to select all the years of interest. So if they're studying a historical population, they might select 1900, 10, 20, 30, etc. For the full count data, we suggest only doing 1 year per extract, and there's two reasons for this. One, again, is file size issue. The other day, I was doing an extract for the presentation today, and I think I selected in 1900. I think it was 4 or 5 variables, so it wasn't very many variables, and I think that was a 4 GB data set. So if you select, you know, more variables than that, which most users do, and then on top of that, you don't just do 1 year, but you did several census years, that file will all of a sudden become a 20 to 30 GB file that most personal computers will be able to handle. So for file size reasons, we suggest only doing 1 year per extract. The other reason we suggest doing 1 year per extract is because of how the MLP crosswalk is designed. It's designed to basically link two data sets together. So if you did for whatever reason, decide I'm just going to download 2 extracts in 2 years into one extract, basically you're going to have to, in order to use it with the MLP crosswalk, you're going to have to go to your extract and separate that file into 2 files. And so you're doing it on your end of the data processing. Whereas if you just let the extract system handle it, it's going to save a lot of computation time on your end because it's going to be handled before you even start the linkage process. Alrighty, I'm just going to select just a few variables here. I'm not going to select very many. We'll just do, I know state FIPS in the MLP crosswalk, but we're sticking with state ICP. That's the researcher that I am. Let's go with sex, age. We'll do race. We'll just do BIPL. We're going to keep MBIPL and FBIPL out of it. I think we'll just do that. Or let's do one more. I know I said be parsimonious in your variable selection, so we're going to do 8 variables for this. But yeah, another suggestion we give is also be parsimonious in your variable selection because again, these files get very large, and again, it's pretty obvious, but the more variables you select, the bigger your file gets, which might mean that it gets large enough to a point that it's extremely difficult to work with. Okay. So you view your cart, you're getting close to finishing the extract here. The last kind of important point, and you don't have to do anything for this step, it's just a point to emphasize for you, is that your extracts, the 2 variables you absolutely need in order to combine your data with the MLP crosswalks are the variable year and hist ID. You don't have to do anything to select these variables. They're pre-selected for you, but you don't want to deselect those variables because you do need those 2 variables in order to link your data to the MLP crosswalks, and then by extension, linking your extracts together. A couple of tips and tricks now. So the first tip I'm going to give is in terms of variable selection, there's a few variables right off the bat here that you can get rid of that you don't really need in your extract. You don't really need the sample variable. It's complete count, full count data. You know what sample it is. It's full count data. The weights are 1. You don't need the household weight or the per weight. The one exception to the weight rule I do want to point out is if you're downloading a sample line variable for the 1940 census data, it's not a pre-selected variable, but you will need the sample line weight for that census. But in general, though, for the household weight and per weight, you don't need those weights in the extract system. GQ is another potential variable you could drop. It's going to be ultimately dependent on your research question. Obviously, if you're studying anyone who lives in a group quarters, you'll need to keep the variable. In terms of For example, in my research, I tend to exclude people who live in group quarters, and so I need to keep GQ in order to make sure I don't include those cases. But if your analysis doesn't rely on whether or not someone's in group quarters, that's another potential variable you could drop as well. And I'm just going to show you really quick. So if we keep all the variables as currently selected, so that file is between 7 to 8 gigabytes currently in size. I'm going to go back now and take those variables out to show you how much space it saves. And it saves just about 2 gigabytes of space. So it's not a small amount of space. I mean, it's saving a decent amount of space in your extracts. So that's definitely some variables that I would recommend not downloading. GQ being again being dependent on your research question, but specifically the weights and the sample variable are variables that you can get rid of right off the bat. Another variable selection that you can't do in the extract system, but you can do once you've downloaded your data, is some of the variables in IPUMS have what's called a general version and a detailed version. So for example, BIPL, the general version codes, again, are general. The one I'm most familiar with is Germany. So here, all Germany for the general coded version is coded as 453. But the detailed coded version of Germany 453, there are, I don't even know how many codes there are, but these are all basically potential codes for Germany. So you might decide based on what your research question is, I don't need the detailed codes. That's a variable you could potentially drop after you download your IPUMS extract, again, to save space. If you do need the detailed codes, then drop the general version. Basically, I guess the point I'm trying to make is you probably only need one of the two versions. So just keep whichever version that you need in your data. Another way to save space is selecting cases. And this is helpful for if you're interested in a particular universe for your analysis. So let's just say, for example, you're studying, we'll just say, I'm just going to use the example of fertility. So you want to study women in childbearing years, so between the ages of 15 and we'll just say 44 in this context. So if you wanted to make your extracts smaller, you could go to the select cases and say, okay, I want to select on sex and age. And then select cases. So you can say, I only want people between the ages of 15 and 44, and I want only women selected. And that will make your extracts significantly smaller depending on your selection criteria. When you do your selection criteria, you can either select only people who meet those case criteria, or if you want everybody who's in a household with at least one person matching those case criteria. You can do either or depending, again, on whatever your research question is. We do want to caution you with the case selection criteria that you need to be careful when you're doing your case selection, because it's very easy to accidentally lose someone in your who we have as a linked person, but because of your case selection criteria, we excluded. An example I'm going to give is, so let's say I'm studying fertility between 1900 and 1910. So I select ever married women in 1900, and I say, okay, I want to select women who are between the ages of 15 and 34, because then by 1910, in theory, they should be 25 to 44. But for whatever reason, in the 1910 census, we have a woman in 1900 who was listed as 34, but now in 1910, they're listed as 45. Well, if I based that on that case selection criteria I just mentioned, we'd lose that potential link in the 1910 data. And that's probably a link we probably do want to keep, because it's a year difference. It's very likely the right person. And so the point of the case selection criteria is just to be as careful as possible with your case selection criteria, because again, there's the potential that you could lose links. 1900. So we'll say women age 15 to 44. So at this point, you could submit your extract. I'm not going to actually submit it because I've already created extracts for this. But the last tip I would give is, so let's just say I've created this 1900 MLP extract. Okay, you've created your first extract. Now you need to create a second extract of your next data set you're interested in, say 1910. The quickest way to do it is just go to revise extract and then change the sample. 1910, unclick on 1900, and it will bring you to the same process. It has all the same variables you selected previously. You'll have to deselect again the weights variable sample that I mentioned earlier. And then if necessary, because of who you're linking, you might need to update your select cases. So originally I had 15 to 34. Now I want 25 to 44. But and then just submit your extract. That's as easy as that. Okay. So after you get the email that your extracts are ready to download, you're going to want to download the IPUMS extracts and your MLP crosswalk to the same directory. And this is mostly for the Stata users. The Stata do file is based on that the files are all saved to the same file location. Once you've done that, these are going to be the general steps you need to follow in order to combine your data sets. Again, I will show you in this for the Stata users what the do file does specifically in a little bit. The first step you're going to need to do is in both of your IPUMS extracts, you need to rename the variables from the variable name to variable name underscore whatever year the data is in. So for example, in your 1900 data, you want to rename hist ID to hist ID underscore 1900. Again, the reason for this is because you need to be able to link your IPUMS extracts to the MLP crosswalk. But we also suggest doing this for all the variables. So serial, pernum, age, sex, race, BIPL, all the variables you download, we recommend renaming the variables to this year, variable name underscore year. And the reason for that is because once you combine your data sets, you're going to want to be able to distinguish data that's from the 1900 census and data from the 1910 census, or again, whatever years you're interested in. And then to combine your IPUMS extracts with the MLP crosswalks, there's kind of two basic rules to keep in mind with how to do this. The first rule is, and I already mentioned this, is always use hist ID. So the variable you're going to use to combine your data sets is hist ID. And then the second rule is whatever the common year is between the two files you're linking is the hist ID you want to use. So if you have a 1900 extract that you want to link to the MLP crosswalk 1900 up to 1910, you're going to want the common year in these two files is now 1900. So you're going to link using hist ID underscore 1900. Once you've merged your first IPUMS extract to the MLP crosswalk, then the next step is to combine the second extract to the MLP crosswalk. So you want to combine your 1910 extract with the above file, combined file, and now the common year now is now 1910. So you're going to combine those two data sets using hist ID underscore 1910. This is going to be a very obvious point, but keeping only the linked cases can make this linked data set a lot smaller. The thing to keep in mind with this, however, is if you're doing any kind of attaching of household characteristics from other members in the household, or you're doing any kind of data aggregation, say at the household level, the county level, whatever kind of aggregation you're doing, you should make sure to do that step before you select only your linked cases. Because obviously if you keep only the linked cases and then try to do some sort of attaching of characteristics or aggregation, you're going to get a misleading number. Okay, let's see. I got 18 minutes. We're doing good on time. Alrighty. So now I'm gonna go over a more advanced case scenario, which is what if you're interested in linking non-consecutive census years? Currently, the crosswalk files are only consecutive census years, so it's 1900 to 1910, 10 to 20, 20 to 30, 30 to 40. But let's say you're interested in linking, say, 1900 to 1940. You can do that using the crosswalk files. The first step we recommend doing for this is to download all the MLP crosswalks. Depending on which years you're interested in linking, you might not need all the crosswalks, but for ease of explanation, I think it's just easiest just to download all of them and have them available. And once you download the MLP crosswalks, you need to combine them together in order of the years of each year. So, for example, if we're linking 1900 to 1940, the first step you're going to want to do is you want to link the 1900 to 1910 MLP crosswalk to the 1910 to 1920 MLP crosswalk. And to do that, we're going to use the same rule as what I just described for the IPUMS extracts and the MLP crosswalk. You use hist ID and the common year in both files. In this case, the common year is 1910, so you're going to combine the two crosswalks together using hist ID underscore 1910. Once you've combined that file together, you're going to need to then combine the next crosswalk, in this case 1920 to 1930. Now the common year is 1920, so you're going to combine those two files using hist ID underscore 1920. And then finally, you're going to do the same thing with the 1930 to 1940 crosswalk using hist ID underscore 1930. Once these files are combined together, you could then select only the cases that are linked between 1900 and 1940. So if the hist ID is missing in either hist ID underscore 1900 or hist ID underscore 1940, that means that's not a linked record between 1900 and 1940, and you can drop that case. If you have hist IDs in both those two variables, you have a linked record, and you can keep that case for linking with your IPUMS extracts. Once you've done that, you can save the file, and I would recommend saving the file in the same format we have the other MLP crosswalks. And again, for the Stata users, the reason why this is important is because the MLP the Stata do file works with non-consecutive census years as well. But the format is basically MLP underscore the first year of your extract underscore the second year of the second extract, or in this case, the crosswalks, underscore version 1.0. That's just for the MLP version .dta for Stata users. Obviously, if you're using a different stats package, you'll rename the file extension to whatever the particular stats package uses. Okay. So I'm going to go over an interactive. I'm first going to quickly go over the do file very quickly, because I know not all of you are Stata users. And then I'm going to go through the actual two examples of linking the MLP data to IPUMS extracts. I'm not going to run it live because I think on my computer it took about 20 minutes to run. So by the time I'd finished running, we would be finishing this presentation. But I do have the logs though to show you how the process works. So for the Stata users, if you download the do file, there's only 3 lines you actually have to edit that will make the do file link your IPUMS extracts together. The first is on line 8 here, which is the local path macro. And basically that just designates where your 2 IPUMS extracts and your MLP crosswalk is saved. And then you need to also edit on lines 10 and 11 the 2 macros here, local extract 1 and extract 2. And these are just the names of your 2 IPUMS extracts you're merging together. You can rename your IPUMS extracts to whatever you want. For the purposes of here, I just kept the names in the exact same format as they were downloaded from the IPUMS webpage. The 2 things to keep in mind here is, number 1, whichever extract is the initial year you're trying to link. So let's say you're trying to link 1900 to 1910 data. The initial year is 1900. Extract 1 should be the initial year. So in this case, extract 1 should be your 1900 data. And then the second thing to keep in mind is don't include the file extension, the .dta, in your macro. Put only the file name in the macro. Just really quickly, I'm going to go over the do file really quick. The first step here renames all the variables to the variable name underscore the year of the file. The next step it does is it determines what years you're actually trying to link. So if you're linking 1900 to 1910, at that point, it's going to try to determine, okay, did you download, do you have that crosswalk? So it's going to look for MLP underscore 1900 underscore 1910. If it finds it, it says, great, move on to the next step. If it doesn't find it, it's going to, specifically in the case of like a non-consecutive year, so you're linking 1900 1940, it looks for MLP underscore 1900 underscore 1940. It's going to look for that file and say, well, it doesn't exist. It doesn't find it. At that point, the stata do file will actually create that crosswalk for you. So for stata users, you don't even actually have to create the MLP crosswalk 1900 to 1940. The do file does it for you automatically. It will determine you want to link 1900 data to 1940 data. Can't find that crosswalk. It will then try to create it. Again, using the same process I just described of merging each crosswalk together in order. At that point, the do file will then join your first IPUMS extract to the MLP crosswalk file. It will then, after it's done that, it joins the second IPUMS extract to the MLP crosswalk file. And then I haven't described this in the process because it's not a necessary part of the process, but the do file does create a linked variable that will indicate the status of a linked record. So if you're, again, going to the 1900-1910 example, the variable will be called link underscore 1900 underscore 1910. And it will give you one of 5 values. A value of 1 means the record only exists in 1900, meaning MLP has not linked that record to anybody in 1910. A value of 2 means the record exists in 1910, but it has not been linked to anybody in 1900. A value of 3 means here's a linked record of someone between your 1900 extract and your 1910 extract. A value of 4 means that the linked record in 1900 was not found. What that means is you have a record in your 1910 extract. It linked to the MLP crosswalk, which means it's supposed to have a linked record in 1900, but because of your case selection criteria in the IPUMS extract system, that record was not selected in 1900. And then a value of 5 is the other way around, where you have a record in your 1900 extract linked to the MLP crosswalk, which means it should have a linked record in 1910, but there was no linked record found in your 1910 extract, which means your case selection criteria excluded that link. And then it will save the file, does a little bit of cleanup, and then it provides a brief summary of the linked records, just telling you how many linked records you have, and then for case selection criteria, how many records were not linked because of your case selection criteria. So now I'm going to just really quickly show you an example of that. So here's, I ran this IPUMS extract this do file earlier. So I updated the 2 extracts. So 223 is 1900 and 224 is 1910 census data. In this case selection for 1900, I selected women between the ages of 15 and 34. For the second extract, I selected women between the ages of 25 and 44. So again, showing you here, it renames the variables, and then it's going to determine what year of which crosswalk you want. So I said 1900, 1910. And so at the bottom of this, it says MLP underscore 1900 underscore 1910 exists. So it just says, okay, great. It moves on to the next step, combines the data sets. And then here at the bottom, I want to show you what that summary looks like. So if you select all the cases, you don't do any case selection, this should be 0. Or I'm sorry, there should be 0 cases from the 2 extracts that were not linked due to case selection. If that's anything other than 0 and you're using all the 100% data, there's something wrong. And that would be a good time to email us at IPUMS because to figure out what's going on. For those who are doing case selection criteria, just to kind of overview this, between 1900 and 1910, based on the extracts I created, there was 3.7 million linked cases. So 89% of the linked cases, not of the records, of the MLP linked cases, 89% of them were linked successfully between your 2 extracts. And then just over 5% of the cases from 1900 and just under 6% of the cases from 1910 were not linked because of the case selection criteria that I selected, in the IPUMS extract system earlier. To give another example, we're going to now look at a case of a non-consecutive census year. So now in this case, I'm linking the 1900 data 223 to an extract 225. And this extract is from 1940. And I believe it's women ages, I think it's 55 to 74, I believe, if I did my math correctly. Hopefully I did. Um, but this is now linking 1900 to 1940 data, again, showing the same thing. But at this step here, I want to just show what it looks different, how it looks differently from the consecutive crosswalks. So it's going to look for MLP underscore 1900 underscore 1940. And it says, oh, couldn't find it. Needs to create the crosswalk file MLP underscore 1900 underscore 1940. And then it provides you updates of where it's linking to. So at this step, it was linking to your 1900 cases to 1920, then to 1930, then to 1940. And then it does, again, the same process. It combines the data, and then it provides a brief summary here. So between 1900 and 1940, just under 600,000 cases were linked between my 1900 extract to 1940. So 94% of the linked records, and just under 20,000 cases from both years were not linked, again, because of the case selection criteria I selected in the IPUMS extract system. So that's something I want to kind of just go over briefly are sources of error in your case selection. So when you have cases that aren't lining up, what's the reason for it? And there's kind of like there's kind of four big reasons that I would look into if you're having issues with your case selection not lining up. The four issues, the first one I would say is what I'm calling historical error. So, and Jonas talked about some of these already, but I'll just give a brief rehash of these. Historical error is basically either the respondent or the enumerator reported information incorrectly. And there's no way to fix this. This is just someone back in 1900 gave the wrong information, or the numerator in 1900 wrote down the wrong information. There's just no way we can correct that because it was recorded incorrectly. Another source of potential error is data transcription error, where the data was recorded by the numerator back in 1900, but in the process of transcribing the records today, someone, whether it was because the form was illegible or they just mistyped some of the information, they just put in the wrong information. And then even though we called this person a link, the information wasn't a transcription. The reason why the information doesn't line up is because there was a data transcription error. And so we code it correctly, but unfortunately it's not correct because it was written down incorrectly by someone when it was transcribed. Another potential error is an IPUMS processing error, which is we have the enumeration, it was recorded correctly by someone, but then when we were coding these cases, we coded it incorrectly. This isn't a great example, but let's just say someone recorded themselves as 33 years old. They wrote down 33 in the ancestry data, but then for whatever reason, I didn't have my coffee that morning or something. When I went to code it, I accidentally coded that age of 33 as 37. That's a potential error, that we coded something incorrectly. That's most likely to happen for longer string variables. So birthplace, relationship to head, occupation, any of those longer string variables, that's more likely to be an error there than in, say, like age. Age is less likely to happen. This isn't necessarily a error in the traditional sense of the word, but another potential area where wide number information might not be lighting up is allocation. So when we code the data, if we can't code something either because it's illegible or doesn't make sense, we code it as missing. And then IPUMS allocates that via hotdeck allocation, which varies depending on the variable for how they do it. But because of allocating processes, it's possible that you'll get information that is not going to be consistent. And that's not an error in the sense that it's wrong. It's an issue of, because the data was missing, we basically made our best guess at what we think it is. One way you can analyze that is downloading the flags in the extract system, which will allow you to understand whether a case was allocated or not for a particular response. And then the final source of kind of error is an MLP linkage error, where Jonas showed you that even though the precision was very high. It's not 100%. There are definitely a few bad links in any linked data set, and it's possible that the person you're looking at is a bad linkage. It's a bad MLP link. Um, and so those are kind of the four like sources of error. And the reason why I want to talk about this is because it has kind of already been brought up in the chat earlier and in earlier discussion. But the literature on race passing of changing of a person's race changing between censuses, and this would be a case of you have to be very clear when you're looking at this of determining which of these cases are actually someone changing the race, and which of these cases are no, it's an error in one of the basically the processing of the data. So I've got 2 minutes left, so I'm going to finish up real quick. Um, if you use our MLP data, you should cite it appropriately, and you should cite it as both. If you're downloading IPUMS USA data, it's citing the IPUMS USA data, but then also citing the IPUMS MLP data as well. You should do it for two reasons. The first reason being the it's the holidays, so we'll call it the naughty or nice list. The nice reason to do it is because if you cite our data, it's going to make it easier for us to justify both maintaining the data set as well as expanding it and making it better in the future. And so the more users we have that are citing it appropriately, the easier it is to show that, hey, this is actually making a difference in the research community. The naughty reason, the other reason you should do it is it's technically a part of your terms of use agreement. Whenever you download and use our data, you agree to cite the data properly. And then this is not part of the Q&A session, but if you have any questions that don't get answered in today's workshop or questions in the future, you can email us at either ipums@umn.edu or ipumsres@umn.edu. Either email address, we will get the information to the correct place. IPUMS is a decent, if it's a general question, you can probably send it there. If it's a detailed question on the MLP data, you can also send it to us at IPUMS Res, and we can help you out as well. I think that's all I got.
All right. We will open it up for